Hi there, welcome to Mr. Morgan's Math Help. This is Algebra 1, and we are looking at Unit 1 today, one variable statistics, and this is going to be lesson number 10 called the effect of extremes, those numbers that are way outside of our normal range of things, okay? Extremes, like extreme heat or extreme cold, okay? So here we go, our learning goals for the day. Let's see how statistics change with the data. So when we start messing around with the data a little bit, what happens to our stats? Learning targets. I can describe how an extreme value will affect the mean and median. So we're going to talk about how we can take an extreme value and how that's going to have an effect on the mean and median. It might make it increase, it might make it decrease, go to the right, go to the left, depending on how you look at things. I can use a shape of distribution to compare the mean and median. So whether that shape happens to be skewed or whatever it might be, we can use that information to compare mean and median. Your warm-up here says that several video games are based on a genre called Battle Royale, in which 100 players are on an island and they fight until only one player remains and is crowned the winner. This type of game can be played in solo mode or in team mode, okay? So this is really activity for you to do in class. What information would you use to determine the top players in each mode? And explain your reasoning there. And the second question here is one person claims the best solo players play game A. They play game A. Another person says the best game that claims that game B has the best solo players. How could you display data to help inform their discussion? So these are things for you to talk about as a class as you warm up today. So you can pause there, have some conversations about those things, and then come back and continue the lesson. All right, use technology. Well, I'm going to use my pencil here to create a dot plot that represents the distribution of the data and then describe the shape of the distribution. So I'm going to do that right here for us. I'm going to draw a line. I have 6, 7, I have 8, going up to 14. So let's start here at 6. We have 7, 8, 9, 10, 11, 12, 13, 14. So 6, 8, 10, 12, and 14. I have 1, 6, I have 1, 7, I have 2 8s, I have 3 9s, I have 4 10s, I have 3 11s, 2 12s, 1 13, and 1 14. All right, so for this shape here, we would definitely, in terms of describing it, we would say this is a bell-shaped distribution there, okay? It's also, we would say it is symmetric, right? Because it's pretty balanced all the way across, isn't it? So that's that nice bell-shaped curve we've talked about before, and it's very balanced there, okay? It then says to find the mean and the median. So to find the mean, we're going to need to add up all those values there. We need to add 6 plus 7 plus 2 8s plus 3 9s plus 4 10s and add that all up and then divide by the number of dots that we have. In this case here we have 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 2. We have 18 altogether. So I'm going to get the total and divide by 18. And when we do that there, if you use your calculator real quick, we're going to find that the mean of this data is 10. The median is going to be the middle value. So we know we have 9 and 9, so we're going to count up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so our data point would be split kind of right there, where we could say this part is half the data there, and then this part is the other half of the data there. Okay, 9 values splitting at 9 at the value right here, the middle, sorry, which is 10. Sorry. So our mean equals 10, and our median equals 10. Nice and balanced, looks great. For number 3, what we're thinking about here is now let's play with some values and add some numbers in and see what happens. Find the mean and median of the data with 2 additional values included as described. So for part A, let's look at part A. We'll make this one in red here. It says add 2 values to the original data set that are greater than 14. Okay, so if I add 2 values over here, let's just say I'm at 15. Actually, let's go ahead and we'll make it 20, right? Even larger numbers there. In adding a larger number over here, we know that now my total number that I'm working with is going to be greater. And when I divide by 18, I know that my mean is going to increase. Okay? Now for the median is still the middle number. While there are two more numbers here, that means that instead of 18 numbers and kind of making a line at the 9th one, I have now 20 numbers, and I'm going to make a line at the 10th value. Well, instead of the 9th value, my 10th value happens to be here, right? And since the 10th value is there at that point, right here, it's still at 10. So the median still equals 10. It hasn't actually changed. Okay? Now let's add two values to the original that are less than 6. So if I come down here and add maybe a 2, a couple over there, all right, now my mean in this case here, I don't know if I think if I'm continuing here, let's pretend we've gotten rid of these guys here. So we're going to say that, oops, I always turn on my eraser on accident. Sorry about that. So let's say we've eliminated this one. Now we're putting some over here. So we're going to put 2 over there now instead of 2 bigger ones. By moving adding 2 values to this side of the dot plot, then I'm going to have a mean that's going to decrease because that total number is going to be less. And so my mean is going to decrease. For the median, the same thing's going to be true. Now I still need to go to the 10th term. And now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10th term is there, but that's still going to be at the value 10. The median still equals 10. So by changing the terms, or changing the, adding a few more points here, I can definitely change the mean by adding greater numbers. If I add big numbers, I can make it increase. But if I add smaller numbers, the mean is going to decrease. But because I'm adding only 2, I have little change with the median. So the idea here is that when I start adding these extreme values out there, extreme values, it's going to have an impact on the mean. But the median is going to have little change, right? Little effect there. So the extreme is going to affect the mean, but not do much to the median. For C, it says add one value that's greater than 14 and one value that's less than 6 to the original data set. So if we come back here and we ignore this here and here, and actually we'll keep it. Let's do this here and that. Whoa, don't do that one. That's too much. Let's see if I can do that. There we go. So let's go ahead and do this here. We're going to add our 2, and we'll add 120 right there. Okay, when I do that, I'm doing it in a balanced way. And so realistically, depending upon what the number is going to be, the mean might be adjusted here and there. This one's a distance of 4. Let's say instead of 14, I did 18. So it's completely balanced there. If I did that, the mean would be the same. And the median is still going to be 10 because I'm just putting 1 on both sides of the thing. Okay? Now, if I then finally go, let's add the values 50 and 100 to the original set. So way out here somewhere, 50 and 100. That's going to definitely cause what for the mean? The mean's going to do what? It's going to super increase because we're definitely pulling the data that way. The median, that middle value there is still going to be 10. Just like adding two 20s, if I add a 50 and 10, the number still splits at that same spot and it's still going to be 10. But adding those big extreme values is really going to skew the data. And we call that mean we're being skewed to the right. Okay, so separated by skew, what we're talking about here, changing that bell into one that is skew changes the mean quite a bit. Okay, create a possible dot plot with at least, creating one, 10 values for each of the conditions listed. Dot plot must have at least 3 values that are different. This is definitely something you can do. Again, there's not going to be a real right answer here. There's going to be several different possibilities because it's what's possible. So the idea here, the first one, is to create a distribution that has both a mean and a median of 10. Okay, So I want to have 10 values. I want the middle value to be at 10. So I'm going to make my dot plot at least have the number 10 on it. Okay, I can have a 9, I can have an 11, I can have an 8, and I can have a 12. So if I want the median to for sure be 10, I'm going to put several dots right here so that I know there's 4 dots right there, that's where most of the values are. I can have 4, 5, 6, 7, 8, 9, 10. And by doing it balanced like that, with a nice bell-shaped curve, I can have a mean and a median of 10 because they're all going to balance out the right way. For the second one, if I want to create a distribution that has both a mean and median of negative 15, I could do the same type of thing. I just start at negative 15. I can have a point here at negative 14 and a point, negative 16 and negative 14 there. I can have 1, 2, 3, 4 values there, or even 5 and 6. I can have 2 there and 2 there. By doing a nice balance there, I can make sure that I have, with a bell-shaped curve, that I'm going to have the mean and median at negative 15. I don't have to have it perfectly bell-shaped like that. I could also do an even distribution. Okay, I could do negative 15. I could do over here at negative 20. I could do a negative 25. I could do a negative 10 and a negative 5. And again, I could have a couple there. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, where it's a nice symmetric and evenly distributed one. But my middle term median's still there, and because these are all equally apart from the middle part, we're going to have a mean and a median that are still going to stay negative 15. Okay, if I want to make a distribution as a median of 2.5 and a mean that's greater than that, now I'm going to need to make it a little skewed, aren't I? Okay, so the middle value is going to be 2.5. So what it tells me is I can do a 1, 2, 3, 4, 5. Something along these lines. 1, 2, 3, 4, 5. And I want my middle value to be here at 2.5. So I want to make sure that I have half the values on this side and the other half on this side. So I can have 1, 2, in this case here, or 1, 2, and 3 would work. And I could do 2 there. So now I have 5 values over here on this side of the line. 6, 7, 8. So I know that my median is going to be somewhere in this spot here if I put the rest of my dots in this section. So now I'm going to put my dots over here and go 1, 2, 3, 4, 5. So I've split it all nicely. So at this point, my middle is definitely going to be at 2.5. And my mean is going to be greater, and that's because this data is going to be skewed to the right, causing the mean to be greater than the median. The next one says a distribution that has a median of 5 and a median greater than the mean. Okay, so if the median is going to be greater than the mean, now we're going to want to skew the data to go to the left, right? So you do the same idea that you did before, but now we're going to want to make sure that our median's at 5 and the other one's the other direction. So we're going to go 1, 2, 3, 4, 5, 6, something along these lines, right? So you're going to have your data points along here, okay, and the other ones can be this way, and that's going to cause the skew to go that direction there, and our middle point's still going to be at the 5. Now for it to be to 5, I should put probably 6 values over here and just 4 values over there so that that becomes my middle point. Okay, so that's a way to do that one right there. Okay, the idea is to see what those extremes are going to do to our values. So the question is always, is it better to use the mean or the median when describing the center? And the answer to that is it really depends. It depends on the types of values that you have and what you're trying to kind of determine or figure out. Okay, the mean gives equal importance to each value, which is got to keep in mind there. So that represents the typical values there. Okay, but it's greatly affected by changes of even one value. So those extremes are going to affect the mean. The median tells you the middle. So even though you have an extreme it's not going to affect it as much. Okay, so here's a dot plot that showing the amount of time a dart takes to hit a target in seconds. The data produces a symmetric distribution. So because that's symmetric and it's just going to curve up and down and up, we could say that the mean is going to be very consistent here. It's going to be great. The middle's going to work. It's symmetric. The mean's going to give you a great answer. You could do the median here as well. It would work just the same. So when it's symmetric, they're both found in the middle, okay? Since the median is the middle value of the data set, you can use symmetry around the center or a symmetric distribution to find it easily. For the mean, you need to know the sum of the distances away from the mean of the values greater than the mean is equal to the sum of the distances away from the mean of the values less than the mean. So basically, you gotta do some math, okay? So symmetry of the symmetric distribution, you can see there are 4 values kind of above, 2 below, 2 above the mean, and 1 value there. So we can see there's some change here for how things work, okay? So that's just kind of the idea. I think I lost one of my graphs. I had another graph somewhere. Sorry about that. There's another graph. That's what this is describing. So there's another graph to look at. It looks something like this, and it has one way down here, another one way down here, and then what happened on the other graph in your book, it's like you have one there, then a bunch, and a bunch, and a bunch, and a few, okay? And so we can see that this thing is not symmetric, which is going to change our mean. It's going to cause the mean to be that way, to be less, and the median won't change too much. So the extremes are going to have an effect on things. They're definitely going to have a larger effect on the mean than they will the median, depending on the number of values you're dealing with, okay? So keep that in mind when you're looking at numbers. Those far extreme values are often what we call outliers, and we'll talk more about that in some upcoming lessons. Okay, so here's your cool down for the day. So look at that, work on that, and share it with your teacher to make sure you're understanding what you're doing today. And then we're going to move on to our homework. Make sure you've done your homework before you're checking it out here, and press play when you're ready to see if you're getting it or not. Number 1, select all the distribution shapes for which it is most often appropriate to use the mean. Well, we like the mean when it's bell-shaped. We like the mean when it is symmetric. And we also like it when it's uniform, okay? So we don't like the skewed or the bimodal. It's not going to work too well because the mean is that average adding things up. You want to have nice balance, nice bell shape, so things are nice and simple. With bimodal, you're going to get those extreme kind of values there. And if it's skewed, you already do have some extreme values that are going to pull the data one direction or the other. For which distribution is it appropriate to use the median? Okay, when it's median, we could definitely say if it's skewed, the median is going to keep the same because you can ignore the extreme values. The number of writing instruments in some teacher's desk is displayed in the dot plot. Which is greater, the mean or the median? Explain your reasoning using the shape of the distribution. So our shape says we're going to go this way and we're going to go up and down. So we can see that we are skewed to the left. Because we're skewed to the left, that tells us that our median is going to be greater than our mean. Why is that? Well, we count the values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Go back 7, 1, 2, 3, 4, 5, 6, 7. Right? So our median is going to be right here between 7, 1, 2, 3, 4, right here. Our median is there at 9.5. The problem is that when I do the average of these values here, that's going to cause my total to decrease, meaning my mean will be less than 9.5. It's going to pull the values in that direction. A student has these scores on their assignments. The teacher is considering dropping the lowest score. What effect does eliminating the lowest value, 0, from the data set have on the mean and the median? And this is kind of a real life thing that does happen. Sometimes your teacher will say, well, get rid of your lowest test grade. Even happens in college too. So the lowest test score is this one here. Well, that 0 has a huge impact because it is an extreme value. And as we said before, the extreme value really affects what? It affects the mean. Is the median going to change too much? Well, let's see what the median is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we go 1, 2, 3, 4, 5. The median value is going to be right here, like 77.5. Getting rid of that 0 is going to do what to the median value? Well, now it's going to be right here. That's my median. So it changes from 77.5 to 80, a little bit of an increase. But the mean, I guarantee, is going to increase a ton because that 0 is probably really hurting the student's grade. So it's going to increase the mean tremendously by getting rid of that outlier. Having it will decrease the overall average. All right, refer to this data. What is the 5-number summary? Well, let's take a look. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we split it at the 5. 1, 2, 3, 4, 5. So 5 values there, 5 values there. So we're going to split it at the 5. Okay. Then we'll split this one at between here and here. So we're going to go to 7. 6, 7 is our other line, our quartile 3. And here we have 1, 2, 3, split right there at the 4 for quartile 1. So there's our box. And 3, 2. Our minimum is here at 2. And our maximum is going to be way over here at 15. Okay, so what do we see here? All right, so that's our 5 numbers here. Okay, so we have our minimum and our maximum. So our 5 numbers are 2, 4, 5, 7, and 15. When the maximum 15 is removed from the data set, what is the 5-number summary? Okay, so if I get rid of the 15, well, now I'm left with 2, 2, 4, 4, 5, 5, 6, 7, 9. My middle value, 1, 2, 3, 4, 5, 6, 7, 8, 9, is going to be the 5th value right here. So there's my middle term there. The split here is going to happen at 3 between 2 and 4. The split here is going to happen at 6.5. And my extreme values are 2 and 9. And when you look at this, it's going to be a little more balanced, isn't it? Right? Not totally though, because that 9 is pretty far out. If you think about it, it's going to be a little further. It's going to be 3 away from quartile 3, and this one's 2 away. But again, much better, not as extreme as what we had up here with the 15. Okay, so that's what happens there. So there you go. That happens there. Number 6, the box plot summarizes test scores for 100 students. So that's the box plot right there that I've written over a little bit. Which term best describes the shape of the distribution? Well, it's not bell-shaped because we have this kind of crazy extreme low score over there. It's not uniform because we can't tell if it's uniform or not with this one because it doesn't show individual values. It certainly looks skewed. And in terms of being symmetric, we would say no, not symmetric. This is definitely just a skewed distribution right there. Our last one, the histogram represents the distribution of lengths and inches of 25 catfish caught in a lake. All right, lovely. If possible, find the mean. Well, to find the mean, what do you need to find the mean? You need numbers, you got to add them up, and then divide by 25. What am I missing right here? I don't have any individual numbers, so I actually can't do that one. It's not possible. Can I find the median? Well, again, to find the median, I need actual numbers so I can kind of line them up and figure out where the middle's at. Do I have actual numbers here? I don't, so I really can't do that either. Were there any fish that were caught that were 12 inches long? Notice that is a precise number. I know that there were fish between 12 and 15. In fact, it looks like there were 6 fish between 12 and 14 there. But do I know if there was one that was exactly 12? I don't. They could have all been 13 right there. They could have all been 14. But I don't have a precise number, so I can't tell. And finally, were any of the fish caught 19 inches? Well, 19 is going to be over here, and we don't have anything after 18, so we would say no, nothing was caught that was 19 inches long. All right, that's it for today's lesson on extremes and the effect of extremes. Hope that helps you out, and we will see you next time. Have a good day.